Hello, I'm Gleb and this is my dynamic spectrum sharing video. In this video, I'm going to tell you about how DSS works on physical layer, how we can test it, and what kind of features may relate to DSS. Let's get started. But please take into consideration this video not a technical advice. This is just for general information purposes. Please use official guidelines, manuals, datasheets, and other technical documentation while working with your network or equipment. First of all, I would like to tell what is dynamic spectrum sharing, advantages and disadvantages of that technology from network point of view. Then I will tell you about how 5G synchronization signal block can be transmitted into the 4G bandwidth without any collocations with other signals. Then I'm going to tell you about such technology as rate matching, and also I will tell you about some aspects related to Uplink DSS. Of course, I will touch a little bit about drive test aspects of DSS cells, and at the end we will try to imagine some possible questions and possible answers related to DSS. One of the main advantages of DSS is the possibility for fast 5G rollout without multi-year and complex refarming. So it can give the users 5G icon on their phones. This is actually the main advantage of DSS, very fast 5G rollout. Just by adding 5G layer and reusing current 4G infrastructure, because DSS is mainly software solution. Mainly it requires just software update. Also, DSS may give us flexible 5G, 4G resource allocation, possible throughput gains. This is of course debatable. It depends on multiple things. It depends on vendor implementation, how well your network works, user allocation, and so on and so on. But in theory, there is a possibility to get throughput gains. And of course, such technology right now in 2022, it has coexistence with many 4G technologies. The disadvantage is actually the main disadvantage, I would say, that we can unreasonably reduce 4G capacity if we underestimate the amount of 4G and 5G users that support DSS mode. So first of all, before DSS implementation in your network, you should very precise, you should put a lot of analysis to understand how many users support DSS in your network, how heavily loaded 4G cells in your 4G clusters, let's say so. So this is very important point. Otherwise, you may get negative effect of DSS deployment in reduction of 4G capacity. One more thing is that not all user equipment support DSS solution. It is also a very important point. Some of software and hardware, they cannot work with DSS. It means that some features of your vendor may not have coexistence with DSS solution. And the final is from user equipment side, from their quality of experience, it may be not so visible the difference between your new 5G DSS network and previous 4G network. In terms of peak throughput, in terms of gains, latency, it may be not so visible, I would say. The main advantage is users will be able to have a 5G icon on their phones and get real 5G experience in net. It should be done very cautiously to understand all negative and positive side of that technology. So let's talk about main points of DSS. DSS allows us to simultaneously transmit 4G and 5G signals in one bandwidth. It can be done on different level, but in most of the cases, as far as I know, it's possible to allocate resources based on resource blocks or even resource elements. DSS mainly is a software solution, as I said before, and it is a kind of a form of advanced scheduler that can operate 4G and 5G signals simultaneously. DSS works only for 5G FR1 bands. This is not because of frequencies or that stuff. This is just by the fact that 4G networks, they usually in almost 100% times works in sub 6 GHz frequencies. DSS on physical and MAC layer, it is a kind of a combination of different technologies such as rate matching, particular SSB transmission into 4G resource grid, and MBSFN subframes transmission as well. In order to share spectrum in a dynamic way, a base station scheduler must be able to solve next thing is to understand how SSB blocks, synchronization signal blocks, which is extremely essential for 5G network and users, how that blocks can be transmitted with PDSCH, with PSS, SSS signals, which is also extremely important for LTE users. How they can be transmitted and in one bandwidth without any collocations, without any possible reductions in accessibility KPIs. 4G cell reference signals, they should not be, they actually cannot be switched off. And this is another challenge for dynamic spectrum sharing, because we should somehow avoid collisions even with that signals. Also 5G channels, PDSCH, PDCCH, corset areas, and DMRS and CSI reference signals, all of that signals and channels, they have to be somehow rate matched around other LTE channels and signals. So this is also can be very challenging. And of course, from user equipment side, user equipment should be able to support DSS mode and understand the current your configuration of DSS. Now let's look at possible way of 5G SSB block transmission in DSS cell. As far as we know, actually, 5G SSB block consists of 4 symbols. This is in time domain. And what does it mean? It means that if we're talking about the same 15 kHz subcarrier spacing, in this case, SSB block cannot be fitted into LTE resource grid. There is not enough space between 4G self-reference signals, between that green signals on my example. Even for the case of MIMA 2x2 and even for the case of MIMA 4x4, in this case even there is less space for SSB transmission. But we all know that 5G SSB block can be transmitted with different subcarrier spacing, with different numerology. And if we transmit SSB block with 30 kHz, it means that in time domain it becomes 2 times shorter. Instead of occupying 4 OFDM symbols, it may occupy just 2 OFDM symbols. I mean, in terms of LTE resource grid. So in this case, it can be fitted just between LTE self-reference signals. Here is another example just for better understanding. You can see that on the second picture, you can see that SSB block with 30 kHz subcarrier spacing can be perfectly fit between 4G self-reference signals. But of course, there is a drawback, kind of a possible negative effect of that transmission, is that SSB block with 30 kHz has shorter time duration, and of course every OFDM symbol has also shorter guard period duration. It means that in very bad radio conditions, we may have some reduction in KPI accessibility 5G, comparing with 4G accessibility, because in that case 4G synchronization blocks and signals will have 15 kHz subcarrier spacing, and 5G SSB will be 30 kHz subcarrier spacing. This is just a regular situation. The shorter guard band in time domain, the more possibility for inter-symbol interference. Here is another example. There is 3 cases for SSB block transmission. We've already discussed the first one. Case is when we try to transmit SSB block with 15 kHz subcarrier spacing. Of course, it will be impossible because in this case SSB block will collide with cell reference signals, as I said. With 30 kHz it is possible, but in some cases, if we start transmission from symbol number 2, like in the right example, in this example, we can see that in case of MIMO 4x4 it may collide, and it actually may collide with, if we try to transmit 5G SSB block within Lte MBSFN subframe. We will talk about it later as well. Probably the one possible point is transmission of SSB block for case B, and start transmission from the symbol number 5 for the symbol number 4. Yeah. Here is MBSFN. So what is it, MBSFN subframe? It came from mobile broadcasting technology that was introduced in earlier LTE releases. As far as I know, it is not so popular. It can be reused for the purpose of DSS mode. So this is a special subframe, MBSFN subframe, that almost empty, and by that fact we can transmit 5G signals and channels inside that subframe. Early 5G releases, they support 6 out of 10 subframes. So it means that we can configure 6 out of 10 such subframes for the purpose of 5G transmission. Information about such configuration can be found in SIB2 block. So regular user equipment would decode SIB2 block and just ignore MBSFN subframe if it does not capable of DSS mode. Next releases, in release 16, it is possible to use even other subframes, not just 6 out of 10 subframes of 4G radio frame. So this is more flexible. Now let's look at structure of MBSFN subframe. As I said before, it is not fully empty. The first symbols, usually first 1 or 2 OFDM symbols, we can see it from left side of the picture. They usually occupied by LTE signals, because we cannot get rid of LTE cell reference signals and LTE PDSCH control channel and other channels. By that reason, first symbols occupied by LTE, but other signals of such physical resource block is fully available for 5G transmission, and we can transmit other 5G signals such as PDSCH area, PDSCH, cell information reference signals, tracking reference signals, and so on. We can even transmit SSB block inside MBSFN subframe. But again, in some cases, in some variations of MIMO, for example, first several symbols in time domain, they can be occupied by LTE. Well, as I said before, MBSFN subframe is one of the possible way for 5G signal transmission. There are some possible configurations that can be found for standalone and non-standalone deployment. User equipment, as I said before, usually read system information and understand if it's DSS capable, it can understand, decode that information and receive 5G channels and signals via MBSFN subframe. Now let's talk about rate matching technology. Rate matching is also can be a part of DSS technology, one of the possible solutions. As I said before, we can use that technology to avoid collisions of 5G channels with 4G cell reference signals. And rate matching can be based on different levels. We can do it on resource block level, so operate just with resource blocks. This usually can be used for Lte, PSS, SSS rate match, for PDSCH rate matching, because they occupy pretty huge areas on Lte grid. And more precise but more complicated rate matching is based on resource elements, actually used for rate matching around 4G cell reference signals. Mini-slot transmission can be used as a form of rate matching for allocation of PDSCH channel, 5G PDSCH channel around 4G cell reference signals. Now let's look at examples. Here we can see our discussed MBSFN-based option. Then right at the center is option with mini-slot based. We can see that in that example it based on either 3 or 2 symbols. So system operate not with a resource block area, with just with few symbols. It has some positive effects. For example, we can switch very fast between 4G and 5G just within a few FDM symbols. But we can see we cannot use some areas, some resource elements right with 4G cell reference signals. And the last option is rate matching. Rate matching based on resource block, as I said before, when we operate with resource blocks. And rate matching based on resource element level, more precise, is when we even can use that areas right with 4G cell reference signals. So it may help us to utilize our spectrum even in a more efficient way, without any overheads. In addition, in some cases, we may need to apply DMRS rate matching. I mean, to use alternative positions of DMRS PDSCH 5G signals to avoid collisions between DMRS and cell reference signals. This information also can be via control information, can be sent to user equipment via control information, and user equipment should be able to receive and understand and work with alternative DMRS positions. Here is an example of a mini-slot allocation. As I said before, we can allocate based on slot and based on symbol level. So mini-slot is actually symbol level allocation. Initially, it was supposed to be used for very fast URLC cases with low latency, but in DSS it can be as a technology for resource allocation as well. And another interesting thing is in release 16 there is a possibility to allocate several LTE bands, work it with one NR band. So for example, we can aggregate 3 Lte carriers, for example 10, 20 and 20 megahertz, and then use it in DSS mode with 50 MHz 5G bandwidth. And all of that carriers will be in DSS mode. I don't have information about vendor implementation. Is it available for May 2022 or not? But in release 16 there is a possibility for such LTE rate matching. And just a few notes about DSS in Uplink. DSS in Uplink is usually less complicated because we should not care too much about collision between different 5G, 4G signals. They already allocated in different time and frequency positions. And in addition, usually Uplink is less heavy traffic, and it may result is more smooth handling. I mean, there is no probability for any uplink reduction in some heavy traffic cases. Of course, one important thing is that user equipment should be able to support 7.5 kHz frequency shift. This is because LTE use single carrier frequency division multiplier access in uplink, and 5G use OFDMA, and because of that difference it also has a difference on frequency raster, and user equipment should align 5G and 4G signals in order to successfully operate in uplink. So, and in addition about synchronization, of course, we understand in order to successfully operate with 5G and 4G, synchronization is very important. In base station, it is of course realized by GPS or by internal clock over packets. But in uplink, it is necessary to align timing advance from 4G and 5G users. So it is also can be challenging for user equipment. Now let's look at this example. Here is 4-step to check if your cell support DSS. So what we can do while you're drive testing, you can try using your testing device, testing smartphones, decode SIB2 from LTE and try to find MBSFN configuration. If you found it, we may remember that initially MBSFN was used for mobile broadcasts, mobile multicast services, and after that we should try to find on the step 2 SIB type number 13. If we find that SIB type, this is not a DSS deployment. This is probably eMBMS. But if we can find only SIB2 with MBSFN transmission, very probably it is very good sign that our cell support DSS mode. In addition to that, we can even further try to verify our DSS cell. We can try to detect 5G NR channels and within LTE signal bandwidth. If it is possible, if it is successfully completed, we can try to find some initial positions for PDSCH DMRS. And if it is completed successfully, we can 100% sure that that cell support DSS deployment. But I believe that first 2 steps would be enough in most of the cases. Here is an example of system information block 2. You can see how it looks like, I mean, in terms of MBSFN configuration. Here is an example, I believe this is from Rohde-Schwarz equipment, how such equipment can show us is it support DMRS alternative positions rate matching technologies or some other features related to DSS or not. And let's try to imagine some possible questions and possible answers related to DSS mode. Well, first question, how to understand if user equipment support DSS? As I said before, any information about MBSFN, rate matching, and so on should be found in the user equipment capability message. This is RC layer. Is there a possible coexistence with narrowband LT or category M? I believe yes, by applying rate matching around LT and NB-IoT signals and category M signals. But of course it may depend on vendor implementation, and you should be aware of that. How fast dynamic resource allocation can be? Well, usually it is on TTI-based level, so about 1 millisecond, but it seems to me that in some cases related to MBSFN transmission, if we use a lot of MBSFN subframes, timings could be a little bit bigger. How DSS mode may influence on non-DSS capable users? Well, sharing of spectrum is absolutely transparent. For regular 4G users, they will just decode SIP to message and skip MBSFN subframes if there is a DSS mode cell. But of course, we understand that we share resources with 5G, and regular 4G users may experience reduction in peak throughput rates, so it can be expected. How non-DSS user would behave connecting to DSS MBSF? Well, actually, I already said about this. They will read system information block and understand if there is 5G transmission, possible 5G transmission or not. DSS deployment can be based on 4G or 5G base station. I would say that the important point here is that DSS hardware should support mixed mode. It means that your baseband and your radio modules should support mixed mode, should work together simultaneously with 4G and 5G signals. This is the main point. How DSS works in Uplink? Well, I've already answered that it is possible, but there is some requirements to user equipment. How DSS may influence on 4G network KPIs? I think this is a very tricky question, because now this is obvious that peak downlink uplink throughput may be reduced, total cell capacity will definitely reduce, latency again can be reduced because we share resources with NR users. But in general cases, there is no degradation in LTE accessibility, retainability, and mobility. If everything is okay, if cell reference signals of 4G cell is not colliding with any other signals, if it works fine and tuned fine, I think we should not expect any degradation in accessibility, mobility, and retainability. Well, does DSS work with ENDC mode or 5G, 4G carrier aggregation features? Of course, as usual, it depends on vendor. It depends on user equipment capabilities to aggregate some specific scenarios and bands. But in general, there aren't any reasons from, let's say, network point of view not to support all of that split data radio beers and uplink, downlink, decoupling features, switching uplink and downlink resources. So I think it is possible. Does DSS work with run sharing features? Again, it it is always depends on vendor, but in general, DSS should be absolutely transparent to run sharing. It is possible to decrease impact on 4G user throughput after activation of DSS mode. I think it is possible. One of the possible way is try to optimize your network, is try to move 4G users from DSS capable cell to other possible 4G layers or even other possible radio access technologies. We can do it by interfrequency load balancing. We can do it manually by tuning different, for example, antenna tilts and so on and so on. By doing that, actually, it is also possible to impact on performance of 5G cells, because it becomes more space for 5G users as well. Does DSS work with indoor solutions? Well, from my point of view, there is no any restrictions for passive and active distributed antenna systems. So, because such DSS mode is absolutely transparent. This is more about logic than about passive antenna elements. So I think it is absolutely possible. And finally, I would like to represent some very, very useful links and references. First of all, I would like to tell you, find MediaTek report. This is a comprehensive deployment guide with all of that nitty-gritty things. They also perform some simulations. You can find very useful numbers, real numbers from simulated networks. Other document is a white paper from Samsung about DSS, also very good for understanding. Of course, some materials from Rode Schwarz. There are 4 very good articles, 4 parts of that articles, some parts related to physical aspects and some parts related to drive test aspects of DSS. Also my strong recommendation. And of course 3GPP. 3GPP also can be very useful as a source of information. That's actually all for today about dynamic spectrum sharing physical layer aspects. If you like this video, you can like and subscribe to my channel. So, goodbye.